For the polynomial, list each real zero and its multiplicity. Determine whether the graph crosses or touches the x-axis at each x-intercept. So we have f of x equals to 3 times x plus 5, x minus 5, q. And we want to find each real zero and its multiplicity and see if the graph touches or crosses. Okay, so our zeros are these, right? We solve for x and we get a 5 for the first one. For this one, we get a 5 with a multiplicity of 1. So multiplicity 1. And what does it do? Does it cross or touch? It crosses the x-axis. Because odd multiplicity crosses and even multiplicity touches. So odd, even, crosses, and touches. Oh, what happened there? Touches. So the other one that we have is, oh, this was a negative 5. So the other one is plus 5. Plus 5 is our 0 with a multiplicity of, yes, you guessed it, 3. So multiplicity 3, and it crosses because the multiplicity is odd. So crosses x-axis. Now, what would happen if we were given f of x equals to 4 x plus 1 times x plus 3 squared? Well, that's easy, right? It's negative 1 multiplicity of 1 and it crosses, right? For the first one. And then you got here negative 3 with a multiplicity of 2. So since the multiplicity is even, then it touches the x-axis. Now let's go do another one. Find the domain of the rational function. How are we going to find the domain of a rational function? Well, let's see. We're given x of x plus 5 times x minus 1. What you want to do is make the bottom part of your rational function equal to 0. Okay? So we need two numbers that makes this equal to 0. Right? So would be x plus 5 equal to 0 and x minus 1 equal to 0. So x equals to plus 1 and x equals to negative 5. So your domain would be x is not equal to negative 5 and x is not equal to 11. To 1. Yes. So there you go. Now, I want to say f of x equals to 8x over x plus 7. Then, what number do we have to put on this x that is going to make this whole thing equal to 0? Negative 7, right? Because negative 7 plus 7 equals to 0. So your domain would be x is not equal to negative 7. And that's it. Now, let's see. We are going to give the equation of the horizontal asymptote. We're given f of x equals to 13x plus 5 over x minus 1. Now we go to our calculator and we input this 13x plus 5 over x minus 1. Graph it, and you can see that second table, there's a horizontal asymptote and, or I have to close the parentheses. Shit. Wait. So 13x plus 5 over x minus 1 parentheses x minus 1. So graph it. Y equals window, put it at negative 15, 15, min at 15, so that you can get a better view of the line at the graph. Yeah. So yeah, you know that your horizontal, there's a horizontal asymptote over here by your, this 13. Yeah, it's 13. So your option is going to say 13, and that's your horizontal asymptote, the imaginary line that goes here that the lines are never going to touch. So 13. Horizontal asymptote at 13. Okay? Now, let's see. Find the vertical asymptotes of the rational function. Okay, vertical asymptotes of f of x equals to 2x over x squared minus 16 x. Okay, you're gonna see that your options, one of your options, it's gonna say x equals to 4 and x equals to negative 4. So go to your calculator and graph it. So 2x over double parentheses because we're going to be multiplying later on, x squared minus 16 times x. Close the parentheses and then just graph it. And here you can see that there are vertical asymptotes at negative 4 and at 4. Right? Let's see. Yes. 4. Right there at 4. Those lines are not touching them. So negative 4 and 4. You can go to your table, see what happens at negative 4, you get an error, and at 4, you also get an error. So there's your answer. Now we're going to give the equation of the oblique asymptote. Okay, oblique asymptote. Let's see. 4 of f of x equals to 4x squared plus 2x over 2x minus 1. And now options, you're going to have your options, and one of them is going to say y equals to 2x plus 2. You will normally have to do long division, but not here. So 2x plus 2, let's see, you're going to graph your function first. So y equals to 4x squared plus 2x over 2x minus 1. on parentheses over here. 2x minus 1. You graph it. There you have your lines. Now we are going to graph our options, which is y equals to 2x plus 2. Let's graph it. 2x plus 2. Graph. And look, it's giving you the oblique asymptote. So that is the answer. Okay?